Okay, so I2c inter-integrated circuit is a protocol. Okay, what is meant by protocol? Protocol means if two devices are there, each device has their own features, right? And then own signals. And then other device also has their own features and then own signals. Okay, I want to communicate between these two devices. We need a protocol because this protocol communicates with this device and according to the another device also. And then whatever the signals are there, that will be connected in this side, and those signals as along with the other signals also connected. Okay, so that is the purpose we are using protocol. Okay, so in this, what are the agenda? What or why I2c is needed? Timings and speeds. After that, electrical topology, how the signals are connected in the electrical topology. And then data transmission format through frames, addressing frames. And then start and stop conditions. What is the start and what is the stop condition? So we will explain that. And then next one is what it called clock switching, acknowledge start and stop, and then acknowledge or negative acknowledgement. So how we will get the acknowledgement or negative acknowledgement? Clock switching and arbitration, debug recovery, verification, and summary. Okay, so these are the topics. In this, what is I2c protocol? Okay, why we need this protocol? So inter-integrated circuit. I2c means inter-integrated circuits. It is used to communicate with low-speed peripheral ICs to microprocessors and microcontrollers. Okay, so intra-band short distance communication purpose we are using I2c protocol. Okay, so short intra-band or low or medium speed purpose it is used for communication purpose. Okay, so widely used in serial communication protocol. Okay, serial communication protocol means you know right how we will transfer the data so serially. Okay, one bit after that and one bit after one bit after. So in that way we will transmit the bits here. Okay, it is a synchronous serial protocol. Okay, with respect to clock, it will be transmitting the data. Okay, it has two wires. One is SDA line and SCL line. Okay, so it is a open drain serial bus. Why it is open drain? Okay, open drain means it has two lines. One is SDA line, that is serial data line, and serial clock line, SCL line. Okay, SDA line and SCL line. Two lines are there. Okay.
అది పిఎల్సి సబ్జెక్ట్ లో ఉంటుంది కదా మైక్రో ప్రాసెసర్ మైక్రో కంట్రోలర్.
हाँ.
ఇక బయట కనెక్ట్ అయితే దీనిలో సార్.
Hmm. Okay. So here what I'm saying, I2c is a inter-integrated circuit. It has two wires. Okay. So two wires. Those are open drain serial bus. Okay. Open drain means what it is meaning. Uh, Everyone is trying to pull the SDA line from high to low.
Yes.
Okay. And then clock is maintained high. But no one is trying to push that low to high. Okay, if you are not using means it is an idle condition. Okay, so it is an idle condition means pull up resistance is there. That pull up resistance is trying to pull that low to high. Okay, so that is the purpose. The pull up resistance are there. Okay, that is the meaning of open drain serial bus. Okay, so it is widely used for serial communication. So and then it is a synchronous protocol. That means data is transmitted with respect to clock. Okay, so see single master and single slave. Here two lines are there: serial data line, SDA line, and SCL line, serial clock line. Okay, so from these two lines we are transmitting the data. Okay, so who is invented by this I2C protocol means Philips Semiconductors in 1982. Okay, so no license is needed in since 2006. Many ICs compatible devices are manufactured. Okay, widely used in protocol. Okay, so it is widely used in protocol. Clear? So here open train I told you, right? So see, single master I2C supports single master multiple slaves communication, multiple masters single slave communication, and multiple master multiple slaves communication. Okay, see, master is sending the data. Okay, so that means I'm saying hello to you. Okay, so and then slave is sending the data. Okay, we say hi other something. Okay, so master is sending address line. Okay, that means master is shouting I'm sending the address. Okay, so then slave will acknowledge it. All slaves will acknowledge it, but which one is the matching one? That slave only it is in the communication. The remaining slaves are keep they are staying keep quiet. Okay, so not communicating any other things. Here, so that is the here open drain means the SDA line and SCL line are connected to so pull up resistance RP. Here pull up resistance that is always connected to VDD. So that's why in SDA line, whenever we are pulling from high to low, it is in busy condition. Otherwise, it is stay on idle. High means it is in idle condition. Okay. So these two lines plays a key role while transmitting the data from master to slave. Okay. So that is the beauty of this I2C protocol. Okay. So only two lanes, simple protocol, and then which can build complex designs. Okay. So and then peripheral ICs to processors and controllers also it will communicate it. Okay, intra-band short distance communication within the devices, it will be communicating effectively. Okay, see, it always multiple devices to communicate with each other by using SDA line. SDA means data line. SCL means clock line. Okay, and I2C operates in two modes, master mode and slave mode. Master mode means master is sending some data, okay, that is doing some write operation. Okay, slave mode means master is receiving the data from the slave, that is read operation. Okay, understood? See, why I square C is needed. Okay, mainly it allows multiple low speed peripheral like EPROM, sensors, and RTC registers, and then PMIC. All these are communicate with the controller using two wires. Okay, only two wires we are communicating with sensors and then EPROMs, RTCs. Okay, so and then PMICs. All these are communicating to your controller through two lines. Okay, so it reduces the pin count. Okay, so pin count will be reduced because two lines only it is transmitting the data. Okay, and then routing complexity means that is also less, and then cost is also less. It supports multiple slaves through. Okay, it supports multiple slaves through addressing and provides reliability using acknowledgement and negative acknowledgement. Means every data transmission it will send acknowledgement or negative acknowledgement. Okay, because we need a response. You receives the data or not. Okay, it sends that acknowledgement means okay successfully receives the data. It sends that negative acknowledgement means okay if there is an error. Okay, in my data there is an error, then it is having we need to retransmit the data or we can check that where the error is exist. So because of these features, I2C is widely used and configured for configure and controlling the embedded as well as soft-based designs. Clear? So every soft-based and then embedded systems we are widely used in this I2C protocol. Okay, there are speeds supports this I2C protocol. What type of speed? Standard speed is 100 kilohertz. Okay, so this is the frequency. Based on the frequency, we can find the delay. Okay, and also we can say that how much speed it is. Okay, so in that way, we will send that. So this is the standard mode 100 kilohertz and fast mode 400 kilohertz. Fast mode plus that is 1 megahertz, and high speed is 3.4 megahertz, and then ultra fast mode that is 5 megahertz. It is used for write only means master only will communicate it, slave will not respond because it have some other features like clock switching. So clock switching means faster master will communicate with the slower slave also. Okay, so that is the main thing. It is available. Even slow devices also there. It will communicate it. Even with delay, it supports that. I will explain. Okay, so that's why ultra fast mode only master only can support that data. So during write operation only it will support that. During read operation it can't support because slow slaves we can't expect that much speed. It is sending the data to master or not. Okay, and then electrical basics. What is that? So I told you that open drain SDA or SCL line with pull-ups. So what is the need of this open drain means whenever everyone is pulling that SDA line to low, from high to low, then only it will communicate the data. Otherwise, it will not communicate the data. Okay, so that's why we are using open drain. Open drain that means it is connected to pull-up resistance. Pull-up resistance always connected to VDD here. Okay, so whatever the device we are using that is pulling from high to low, this is the high level, and then pulling from low. Okay, again it is in idle condition means it is pulling to low to high. Okay, it is pushing from low to high through pull up resistances. Okay, so when NMOS is turns off, SDA line or SCL line released and returns to high from pull up resistance. Okay, so high from the pull up resistance. That means so initially it is in high. Okay, it is pulling to low. Whenever that this MOS transistor is off condition, then there is no signal transmitting here. Then it is pulling from low to high by using pull-up resistance. Okay, so what is that exponential rise depends means on the capacity. Exponential rise depends on capacitance on the SDA or SCL line and pull-up resistor size. Okay, so based on the pull-up resistance size, it depends upon it tells about the size. Okay, because delay T equal to what is the formula? Delay T equal to RC, right? Okay, so we are using RC means resistance and capacitance. If we are using low resistance, okay, faster communication because resistance is low means delay also low. Okay, resistance is high means delay also high. Okay, so here I'm using low resistance. That means more power is consumed because faster response, right? If you are doing faster response means, so I'm doing faster communication, I can also consume more energy, right? Same way here also it is doing. It is doing faster communication means it also consumes that more power. Okay, if it is resistance is high, okay, high resistance means resistance is high means delay is also high. Okay, delay also high means the communication should be slower because it depends upon the delay. Delay is high, that means how the delay is high, you are saying that depends upon the capacitance and resistance. If your resistance is high, then your delay is also high. Therefore, the communication is slower. And then if your communication is slower means your consuming energy is also low. That's why power is also consuming low. Okay, these are the electrical basics. See, rise time limited is depends upon the time constant T and C. Sorry, R and C, resistance and capacitance. See, wire and means Any low wins means if you are sending some address, either 10 10 1, okay, and other address 01 01, okay, 010, and other address 01 10 0 So now tell me which address is communicating first here? Which address it is communicating first? Here low wires wins, right? So any low wins means, see, here one is there in the most significant bit, okay, that is high, right? That address is high, and here ms bit is 0 is there, here also 0 is there. Then compare the next MSB bit, here 1 is there, here also 1 is there, and then second one is second one address, third bit is 0, here third bit is 1. That means this value is low, okay. So low address, it will wins the race, okay. So that is the meaning of wire done, because it is supposed that low SDA line, whenever it is pulling from high to low, it is in busy condition. That's why low address wins the race, okay. And this is the pull up sizing. So TR, that means rise time depends upon the time constant RC, right? Resistance and capacitance values we are increasing means, suppose I am supporting 400 kilohertz.
Yes, sir.
Okay, 400 kilohertz, that is approximately equal to, see, 1 by 400 means, so what is the value? 1 by 400, so kilo means 10 power 3. Okay, so rise time is less than or equal to uh, approximately 300 nanoseconds. Okay,
Yes, sir.
so here I am saying that capacitance value is 100 picofarads, and then resistance value is 3.5 kilo ohms. Then we can multiply these two values. You will get the approximately value, rise time value 300 nanoseconds. Just apply it here. Okay, resistance value is 3.5. Here is 100. 100 into, so here kilo means 10 power 3. 10 power 3 into 10 power 2. That is 10 power 5. Okay, 3.5 into 10 to the power of 5. Okay, pico means 10 to the power of minus 9. Okay, so 10 to the power of minus 3 means milli, 10 to the power of minus 6 means micro, 10 to the power of minus 9 means pico, 10 to the power of minus 12 means femto, and then 10 to the power of minus 15 means some zeta, so something there. So I think femto, hecto, something, I don't know. So we'll see that. Okay. So and then see 10 to the power of minus 15, sorry, 10 to the power of minus 9 and 10 to the power of 5. So 10 to the power of minus 4. Okay. And then here 10 to the power of 3.5, that is 10 to the power of minus 1. Then 10 to the power of minus 6. 3.5 10 to the power of minus 6 approximately is mentioned at 300 nanoseconds. Okay. So that means we need to multiply with another 1000 value, and then we will divide it by 1000 and then multiply by 1000, we will get, so 300 nanoseconds we will get. Okay. See, that is the pull up distance sizing here. This is the frame structure. So how the data is communicating from transmitting side to receiving side. Okay. Up to this clear. So how we are sending the data, so and then how we are receiving. Okay, so this picofarads conversion means, see, TR equal to 0.8473 into R into C. R value is 300. R value is 3.5 kilo ohms and C value is 100 picoseconds, picofarads. Okay, 10 to the power of minus 3 means milli, 10 to the power of minus 6 means micro, 10 to the power of minus 9 means nano, 10 to the power of minus 12 means pico, and then 10 to the power of minus 15 means femto. Okay, 10 to the power of 3 means kilo, 10 to the power of 6 mega, 10 to the power of 9 means giga, 10 to the power of 12 means tera, and then 10 to the power of 15 means geta. Okay, so that is the values. Now you got right. So how we are converting the data? See, next one is frame format, frame structure. That means how the message is transmitted. Okay, so here start condition is there. Start means I said that, right? So depends upon the start condition you are saying hi. Okay, so her hello. Stop condition means okay, goodbye, say goodbye. Okay, so that is the start and stop condition. And then address, it is sending that address. Okay, I need, so master is shouting like anything, so I want this address. Okay, and slaves are also in that same way it is also shouting.
Yes.
Okay, so but which slave is matching, okay, that slave only is communicating.
Yes.
Clear? So that is the meaning of address sending. Okay. So next 8 bit here up to here address is 7 bits or 10 bits it is supporting. Okay. Address is 7 bits or 10 bits is supporting. That means 10 bits means more slaves you want to communicate it. Okay. More complex design you are designing means then you can go for 10 bits. Otherwise it is an optional. Up to 7 bit is enough. Okay, 247 means 128. Okay, up to 128 slaves it can be communicated. Okay, so and then 8 bit is read or write bit here. If it is 0 means doing write operation. If it is 1 means doing read operation. That means right bit is a or right pin is a lower pin. Okay, read pin is the higher pin. So that means write is operating on active low pin and read is operating on active high pin. Okay, so based on that it will send that read or write bit. Reading means slave is sending data to master. Writing means master is sending data to slaves. Okay, and then acknowledgement or negative acknowledgement. Here also acknowledgement bit is the lower pin. Okay, if it is sending 0 means okay, sending message is sending successfully, and you are acknowledging. Each and every data transfer we need to acknowledge.
Yes, sir.
Each and every address transfer we need to acknowledge that. Okay, so that's what. And then negative acknowledgement means it is sending one. Okay, you are getting some error that indicates that negative acknowledgement. After that, data frame one, acknowledgement or negative acknowledgement. Data frame two, acknowledgement or negative acknowledgement. Data frame three depends upon your data size. Those many data are transmitting. Each and every time, one data frame, 8 bits are transmitting. Okay, and then stop it. So I'm saying goodbye. Okay, so then it is stopping the communication. So now we can see what is start condition. How we will communicate the start condition. See, start begins. See, communication begins. Okay, with start condition. Master sends that master device pulls that SDA line from high to low. Okay, while keeping that SCL is high. Okay, so initially your SDA line should be in high condition. Then master is pulling that SDA high to low. This is the SDA pin. Okay, so this is the SDA pin. We are pulling from high to low. Master is pulling from high to low, while keeping that SCL is high. Okay, so while pulling from SCL SDL line from high to low and keeping that SCL should be high. Okay, let's see here. This is the low line. Okay, so this is the low line SDA line. Okay, but still this SCL line should be low only. After SDA line completely pulls low, then only SCL line should be keeping high. Okay, That is the start condition expression. See, SCL SDA line is changing here. Okay, while keeping the SCL should be high.
Yes, sir.
Here only it is getting this condition. Remaining all conditions, SDA can't be changed. SDA should be maintained stable. Otherwise, it is violating your protocol. Okay. So during that, so the data is not transmitting. Therefore, it is not transmitting, right? So we are changing that SDA line. So from continuously changing means then as we are maintaining clock high means then there is no use. Communication is not happening properly because every time you are changing means which data I want to communicate it. That should not be happen. That is I2c protocol violation. When you can change the data, SCL should be in low condition. So SCL should be in low condition. You can change the data. HDL line you can change anytime. Okay, that is possible. That is not the violation of I2C protocol. Okay, so if you are maintaining clock high and you are changing the SDL line continuously means that is violating and no data is receiving at the slave side. Then you will get the some garbage value or unknown value. Okay, so that is the reason you can't change the SDL line. Okay, during SCL should be high condition. There is an exceptional case. It is start condition and stop condition. During start condition, SDA is pulling from high to low by the master and then keeping that SCL should be high. Okay. So initially SDA should be in high condition and pulling from high to low. So first SDA line should it is in low condition, that is in busy condition. Based on that, SCL should be little bit delay and then after that it is getting high.
Yes.
Okay, this condition you need to explain to the interviewer. Okay, and then addressing. I told you that addressing is having after start condition, the master sends that 7-bit address. That means master is asking who is having this address, and then we need to respond. Slave need to respond. I am the matching address, so I am the person to communicate with you. Then it will start the communication. After start condition, master will send the uh, address bit. That is
So, why
7-bit address.
delay why
Which one?
from a diagram?
That
Delay
is
why
delay means see here clock signal is not putting that high immediately because same line, same master clock only controlled by the master. So master only pulling from high to low. Okay. After that it is pulling from high to low. Then immediately slight delay is there, and then so we are maintaining that clock signal should be high. Okay, so that is the reason it is having some smaller delay. Okay, see how the slave is communicating. It is sending that 7-bit address and to the target slave. With the 8-bit is used to indicate that read or write operation. I told you that 7 bits and then including that read or write bit, that is the 8-bit. It is sending that. Okay, then slave compares. Okay, its own address with this address, whatever the address sending by the master, okay, slave will compare that with own address. If the address matches, the corresponding slave device acknowledge to the master. Okay, and the perfect address what you are sending. Okay, so this is matching with my slave. Okay, then master is communicating that slave. Then data transfer, how the data is transferring. Once the slave is acknowledged, okay, once the slave is acknowledged, the address data can be transferred between the master and slave. Okay, see here read or write bit. So write bit is should be one means here one we are maintaining means master sending the data to slave, and then zero means master receiving the data from the slave. Okay, so here I am mentioning one and zero. Okay, depends upon the one it is doing that master operations. That means write operation. It is 0 means it is doing the read operation. Okay. Acknowledgement bit. Acknowledgement bit after sending one data frame. If the data frame is received successfully, the slave we need to acknowledge. Okay. The acknowledgement bit sent to the master by the slave. Okay, I am received the data successfully. Okay, slave will acknowledge to that data. Slave, I have received the data successfully. Okay, stop condition. When the stop condition is happened, so here I am sending the data when the communication is complete. Okay, so the master sends that stop condition. Sharing the screen.
Yes.
Now, okay, screen is coming.
Yeah.
Okay, stop condition means when the communication is completed, master will send the stop condition by releasing that SDA line from low to high. Okay, during low condition it is in busy. Okay, whenever this SDA line pulling from low to high, okay, it pushes from low to high, then it is idle condition while keeping that SCL should be high. I told you, right? So start condition, how it is happening while SCL line is pulling from high to low, and then SDA line should line should be maintained high. Okay, and then this SDA line is coming from low to high. Okay, so after that, below before that only the clock should be maintained low to high. Okay, so it is going from low to high. Okay, so that means, see, that is the stop condition. There is a some delay. Okay, so entire the communication SDA should be the most communicating device. Okay, it is in the most communication time. It is more and more time in communication. That is the SDA line. So SDA line should be less communication. So because after pulling from SDA line high to low, after that clock is setting. Okay, and then before that your keeping low to high. Okay, SDA line before that only clock should be going low. Okay, after that it is going high. Okay, so then we don't know how much time it is maintained high or low. Okay, so that is the stop condition. Clear? See, address bit. Most common usage is 7-bit address. Okay, address or use is 7-bit address, and then 10-bit is an optional. Okay, and then reserve ranges and general call. Okay, some ranges it will be reserved. That means 7-bit address means 0, 0. Okay, 0. So 0. Okay, 0, 5 zeros and 6 zero, and then 7 zeros. Okay, so these zeros to all ones, one, 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 one. Between that, any type of address it is sending, right? So that is the 7-bit address, and then there is a reserved ranges. Okay, so from starting from 0 to 1111. See, 7-bit address immediately followed by read or write bit. Okay, to avoid collisions and map early. So which one is doing write operation, which one is doing read operation, we need to know that. Okay, so that's why we are sending the 8-bit is read or write bit. See, 10-bit addressing as an I2 square C or I square C grows beyond small systems. Okay, for large or complex systems we can use the 10-bit address. Okay, where the 10-bit address it is used complex socks, system on chips, or large sensors, large sensor arrays, or automotive buses and multi-slave environment.
Yes.
Okay, so during that it sends that 10-bit addressing. Okay, 10-bit. address base. Okay. So 128 is become too few. That is 10 to power 7 means 128, right? So 128 is for large complex designs or socks, it should be too few. Because 10 to the power of 10 means 2 power 10 means 1024. Up to 1024 bits it is sending. See, single master with multiple slaves. How it will be communicating? So because I2c uses addressing, that means multiple slaves can be controlled from a single master. Okay. Single master will communicate that it's sending uh, different address locations. Okay. See, 7-bit means 128 addresses. Okay. So 128 addresses, that unique addresses are available. So most of it, so 128 unique addresses are available. And then using 10-bit 1024 unique addresses are available. Okay. But so uncommon but provides 1024. So in that 210 means most common time. Most commonly it is sending that unique addresses. Okay, practically. Okay. See how it is connected to connect multiple slaves to a single master. So wire them like a with 4.7 kilo ohms pull up resistance, and then connecting that SDA line and SCL line to VCC. See here SDA line is connected and SCL line is connected. We need to connect this SDA line and SCL line with pull-up resistance. Okay, this is the pull-up resistance RP value. That RP is 4.7 kilo ohms. Previously we can take that 3.5. Okay, so and then now we can mention that 4.7. So then approximately 300 nanoseconds delay it will get, obviously, because it is increased, right, resistance. So this resistance will pulling from low to high. Okay, so whenever that bus is released, means it is no one is pulling to low to high. So pull up resistance only is doing that. Okay, because it is already connected to supply voltage VCC and or VDD. Okay, see I told you, right. So master one communicate with slave one, or master is communicating with slave 2, or master is communicating with slave 3. How it is communicating means it depends upon the address. See, it is sending that address is 50 for writing the data, and then 6 this is communicating with 6 8, so for reading the data, and then 7 7, so write configuration. Three slaves, three different operations are doing. Now tell me which slave is communicating first. So 50 is the lower address, right? The first slave is communicating first. That means doing the right operation. And then second slave, that is 68. Okay, address is 68 compared to the 77. 68 is lower. Then reading the data. After that, and then 77, then it is doing some configuration, right configuration. See, each transition is independent and separated by start and stop condition. Okay, so while right condition, if you are doing right condition, so it will do that start and stop condition. During that only, it is sending the right operation. And then read operation. So if you want to do the read operation, then again, if it is stopped, and then again it is communicating with. So say, sending some address and then communicating with read or write operation, and then data frame it is receiving. So reading operation is doing that. And similarly, write configuration. After stopping the read operation, it will do that write configuration. Clear? See, multiple masters with multiple slaves. How it is communicating? Multiple masters can be connected to a single slave or multiple slaves. Okay, I2c supports that multiple masters and multiple slaves because it is the combination of whatever the best features are available in SPI, serial peripheral interconnect, and UART, universal asynchronous receiver and transmitter. So both those best features are implemented in SDA, sorry, I2c protocol. that is the communication happens here. See, multiple masters, how multiple masters are communicating. Multiple masters can be connected to a single slave or multiple slave. The problem with the multiple masters is the same system comes. Okay, same system comes when two masters try to send or receive the data at the same time. Okay, over the SDA line. So there is a problem, right? So two masters in that to solve this problem. So each master has a need to detect that SDA line is low or high before transmitting the message, right? So I told you this is a wired AND gate. Wired AND gate means whoever the low address, that only wins the race. Okay, here also multiple masters at a time communicating on the same SDN line, then we have an issue. Okay, at that time it can see the address which address is low. See, if the SDA line is low, this means that another master has control on the bus because it is already in low condition. That means someone is doing some other operation with that SDA line. Okay, so now it sends that see to other must and the master should be wait to send the message. If the SDA line is high, then it saves to transmit the message. Okay, I told you. So if it is high means SDA line should be high means it is in idle condition. So to connect multiple master to multiple slaves, use the following diagram like 4.7 kilo ohms pull up resistance and connecting with the SDA line and SDL line to VCC. So previous diagram only same way. Here also multiple masters and multiple slaves. See one master one, master two, master three. Okay, multiple masters I am having. Okay, I2c supports that multiple masters and multiple slaves communication on two-wire bus, both the SDA line and SCL line. See, here SDA line and SCL line is connected to VCC through pull-up resistance. Okay, see if master start at the same time, see arbitration occurs. Okay, I told you that. See, it is a wide and gate nature. So, wide and gate nature, wide and nature of the SDA line. The master sends that device a one bit and reads as a zero. That means it is loses the arbitration because I am sending one bit, but it is showing that zero. That means at, at any time you are losing the arbitration because every time it is showing that idle condition, but it is busy condition. Never communicate with the master, right? Master is never communicating with the that slave because I am saying that okay, I am in idle condition, but I'm not say idle condition. So I'm busy with some other master. Okay, I'm communicating more. Okay, but you are saying that you are saying I'm busy. I'm idle condition. That's why you are sending the data. Okay, but I'm not ready to receive the data because I'm communicating with the other person. Okay, I'm not taking the class this time. So, so this 7:30 to 9:30, I'm in other class. Why I need to take the class to you? Why you are coming to the class? Okay, so then, so during my busy condition, you are coming to the class. So that means wrong communication is happening. That means arbitration is lost. Communication is mismatched. So due to lack of communication, you came at early and then sitting idle condition. Okay, so that will happen. That is the arbitration loss here. Now, slaves are selected by the address, and only the addressed slave responds with the acknowledgement. Okay, I told you. So, whatever the address we are sending, so that address is communicating. Okay, that slave is only responding to the master. Okay, I'm the perfect match. Okay, I'm communicating with you. So now, so my master is communicating with that slave. The data is obviously it is sending. Okay, see it supports that clock stretching. So clock stretching ensures that slow slaves can safely communicate with even though it is communicating with multi-master systems. That means faster master systems are also communicating with the slower devs. Okay, slower slaves. If communication is happens. Okay, So no problem in that. So this is the timing diagram. See, so previously I told that write equal to 1, okay, that is doing write operation, and then 0. See here, read or write bit is a 0 pin, okay, write bar is there, okay, that is active low pin. That means 1 means master wants to send the data to the slave devices. Okay, 0 means master wants to write to the slave devices. Okay, see 1 means master wants the read from the slave devices. That means it is doing the read operation. 0 means master wants to send the communication, send the data to slave. That is the write operation. Okay. See, frame address, so A6, A5, so 7-bit address. First is the most significant bit is communicating. Every time, so data is communicating with most significant bit. Okay, so that means suppose you are sending 10, okay, so 10, okay, 101, okay, and then 0 you are sending. This 0 is indicating that write operation. These 7 bits are the address. Here, this beside the 0, this is LSB bit, least significant bit, and this is the MSB bit, most significant bit. Okay, this is sending first. Okay, next slide. So based on that most significant bit, which one is the most significant bit is 0, that is communicating first. Okay, which one is the one is there means that is the highest bit address. That address is not communicating. It will communicate later. Okay. See, every address it is maintaining clock high. Address 6, address 5 clock is there, address 4 clock is there, address 3 clock is there, address 2 clock is there, address 1 clock is there, address 0 clock is there. Similarly, data. So see, this bit is indicating that idle condition. During that, we can send the acknowledgement bit. Okay. See, read or write bit, it is sending that still it is low condition and clock is high. At that time, acknowledgement is sending. See, this is the acknowledgement bit communication. Okay. So this red mark indicates that after read or write bit, it is staying that low. Okay, and then clock is high. That means they are sending acknowledgement. Okay, and receiving the data perfectly. And then so after that data 7 address is there, clock is there, data 6 clock is there, data 5 clock is there, data 4 clock is there, data 3 clock is there, data 2, data 1 and data 0. Every time the clock is there. Still this bit is still low. Okay. So this low condition it is sending that acknowledgement bit. Okay. So after sending the data we need to send the acknowledgement. Okay, after receiving the data, we need to send the acknowledgement. Every transfer happens, we need to send the acknowledgement. Okay, so this is the data frame. So this is the timing diagram, how the data is transmitted. Clear?